My name is Ryan Babcock, and my group members' names are Will Milholland and Nolan Crocker. We made a concrete canoe for our FEDD competition. Now, I was in charge of designing, so I'll be walking you guys through the design process. The first thing you want to do is ask questions, figure things out. The first question you should ask is, what am I actually doing? And in our case, we're making a concrete canoe. Now I want to know, what's my constraints on it? What's the size it has to be? What's it trying to accomplish? Now, our size constraints were 18 inches long by 6 inches wide by 5.5 tall. So, great, I know what I'm doing. I know how large it's supposed to be. Now what am I trying to accomplish with it? We had to make a canoe out of concrete to hold the most weight without sinking. And now that I know what I'm trying to accomplish, I know my constraints, and I know what I'm doing, I need to do some research to figure out how to do that better. So the first thing I need to understand is Archimedes' principle. This involves water and buoyancy. So you can see the water's at this fill line here. And if I take this rubber ball and drop it in, the water's now a little bit above the line, but the ball sank. So we take the volume of the water above the line and calculate what that mass would be, and that becomes what would be known as our buoyancy force, or a force pointing upwards. Now the downward force is the gravitational force exerted on the ball. That determines how much force is pushing down against the water. Now this sank because the downward force was greater than the buoyancy force pushing upwards. Now if I take this foam block, you can see if I hold it under the water, it displaces a little bit of water, but not quite as much as the ball. But if I place it on top of the water, like I did with the ball, this time it floats. This is because the force exerted by the buoyancy, if I were to hold it under, is greater than the gravitational force on the foam itself, and that causes it to float. So now I know how to make something float. So now I have to figure out what my concrete consistency needs to be to form a better mold. Now I also need to take water absorption into account and figure out how to reduce that, because concrete is naturally porous, and as the concrete absorbs water, it's increasing the weight of my canoe. And that increases my downward force, which makes the net force difference between the upward and downward force less. So it'll be less buoyant. Now, I also need to figure out how to deal with the expansion during the curing process. As concrete cures, it expands a little bit. Now, that can cause it to crack as it's hardening. And this can be reduced by adding more aggregate, which allows it to move just a little bit as it's curing to reduce the cracking. And now I have to figure out how curing affects the actual strength of the concrete, which it doesn't affect the density. So now how does it affect how strong the concrete is? The longer you let your concrete cure and the more humid environment you let it cure in, the stronger it's going to be, because the reaction occurs when water is added to the cement mix, and that's what causes it to harden. So now that I've done my research and I've answered my questions, now I need to imagine. That's our imagine portion of this. This is kind of your brainstorming, your design drawing, your mold making. So when it comes to the shape and the design of our canoe, how do we make it most buoyant? Well, that's easy. You maximize the volume of the canoe. That means make it as wide as possible, as tall as possible, and as long as possible, while still fitting within the size constraints. And by doing that, we can make a mold like this. And we decided to go the route of almost kind of like frosting a cake, where this would be our cake and the concrete was the frosting. So we put that over the top of this, and then let it cure, and then break this out. We broke this into two pieces so you can pull it out one part at a time to make it a little easier. Now we need to figure out now we need to plan. I have my mold, I have my shape, now I need to plan. What are my aggregate ratios? How am I going to let this cure without cracking it? So we left ours covered while it dried in order to allow it to cure a little more slowly. And for our aggregate ratios, we decided to use 1 part cement, 2 parts sand, and 1 part styrofoam in order to make it a little bit lighter. Now, our first one cracked, so it came time for improvement. We found out it was because we added too much water to the first concrete mix, which made it too porous, and that's why it cracked. So a little bit less water ended up making the second canoe great. So now it floats, it's the right shape, But there's one problem I still haven't addressed, which I figured out in my research portion. That's water absorption. Now when we have our canoe here, which is our finished product, we covered the outside in a cement to water paste, almost kind of like a paint, because the cement absorbs less water because the cement itself is less porous than the cement plus the aggregate. And that also made it smoother on the outside and made it a little bit easier to kind of sand down and smooth out to allow it to displace more water. Now, Will is going to talk to you about how the actual FEDD day went, and then Nolan is going to give a little tips and pointers on things we did right and some things we did well.
This would have made us more competitive due to the fact that other groups' canoes were a whole lot lighter than ours were. One example of this is other groups used just styrofoam as an aggregate, and we used sand and styrofoam. If we just would have used styrofoam, our canoe would have floated a whole lot better than it did, but still 8th place is not bad. However, in order to improve on that, we definitely should have considered not using sand and using more styrofoam.
Next off, pay attention to the requirements in the rubric. So make sure that the canoe fits within the size dimensions given. That's something that we kind of were pushing the boundaries with, like our width and stuff like that. Also, be sure that the canoe follows the other shape guidelines in the rubric. Things like having a V-shaped hull and just being generally canoe-shaped. Also communicate with other groups just to exchange ideas. If you're having trouble with things, they can help out because they're doing the same thing you are. And lastly, and most importantly, I'd say, do not buy too much concrete. The canoes, they don't actually require that much concrete. We poured 2 and only ended up using about 5 pounds, and we had a lot left over.